So just a really quick background on who I am. My name's Dan Gottlieb. I recently started a small consulting firm to do FHIR-related consulting, but before that, I was a technical lead at the SMART on HL7 project, and before that, I was working on data at the New York City Department of Health. So I've been spending a bunch of years working on open standards and open source software. And about 2 years ago, Josh Mandel and I started a project to really enhance the FHIR APIs to support bulk data or population level data sets. But I want to make it clear that the work I'm going to talk about today is the work of a lot of people in the HL7 community, as well as support by the SMART on HL7 project, the Argonaut project, and the Office of the National Coordinator for Health IT. So this is not just my work I'm talking about, this is the work of a lot of really great people who put a lot of effort into it. So when we talk about bulk data, or population level data, what are we really talking about? And so I wanted to start with 3 examples that kind of came up in my work over the last few years. The first was a large academic medical center that had a project where they were having some care provided in a third-party clinic, and then the patient's main record was stored in this hospital. And in order to get the data from the clinic into the hospital, they created a project where they did a careful field mapping of fields from the third-party EHR, dumped them into a CSV file every night, had that FTP'd into the hospital's network, and then on the hospital end, they did an ETL process where they did that mapping in reverse and figured out how all those fields fit in to their Epic system. And so that worked, but it's a very manual process on both ends, and of course it's pretty brittle, right? If either EHR changes their data structures or changes how the screens look, and so the data's used or the fields are used in a slightly different way, that'll break and have to be redone. Similarly, a healthcare institution I worked with had a third-party population health system for care managers. And they had the same issue. They wanted to get data from their EHR into this third-party system. And they came up with a similar solution where they did manual field mappings and then had a periodic data dump from one system to the other. The third example is actually FHIR-related. So this was a startup that had a machine learning algorithm that made care recommendations. And a clinician group wanted to use this at their practices. And so they contracted with the startup, which needed to tune its model with that physician group's data. And so they were using a cloud EHR that supported a FHIR interface. And they realized that if they incremented each patient ID by 1, they could kind of walk through all the patients. So what they did is a series of hundreds of thousands of queries where they kind of asked the system for every possible permutation of FHIR data that was there and tried to pull it down. And sometimes it worked, and sometimes it failed, and sometimes things timed out. But eventually they got a fair amount of data. And this example is like a year old, but I went to a talk yesterday here where somebody described doing the exact same thing. And they actually said that they ran into audit limits because there were so many logs from the queries that it kind of broke the system they were pulling data from. So this is not really a solved problem at this point, which is a little surprising. There are a lot of really other common use cases for moving around these bulk level, population level data sets where you're not looking at data on 1 or 2 patients or even a small panel, but you're trying to get data on a large group of patients. Payers are really anxious to be able to get data from clinicians to assess care quality. And right now this is done using a lot of this proprietary CSV mapping, sometimes even faxes, collecting data from manual chart reviews. And so they're really looking for a much more efficient way to do this. And on the other side, providers want to be able to get claims data so they can get kind of a 360-degree view of where patients are getting care outside of their system. And so both sides really want bulk data to be transmitted. A really common use case is for hospitals to have a research data warehouse and dump data from one EHR or even multiple EHRs into this data warehouse to find study cohorts and to do analytics. And so that's another use case. And then the last use case I'm going to talk about, or I want to mention here, although you can probably think of many, many others, is reportable disease registry submission. So if you have a healthcare institution, they may see several thousand patients a day who need to be, where there are registries that need to be notified about those patients' conditions. And right now, again, that's often a custom process for each registry. Some of them have FHIR support, but it's still kind of cumbersome for large numbers of patients, or building FHIR support. And so what it really comes down to is that these manual processes are very cumbersome, right? You have this manual process of mapping the data in and out. Usually to kick off these data dumps, there's either a manual process or a proprietary vendor solution to start those. But in either case, every healthcare institution does it slightly differently. And then the last point is that the FHIR API is incredible and really powerful and great for these single patient or small panel use cases, but it's not really designed to support getting hundreds of thousands or millions of FHIR resources in and out of systems. But at the same time, we've spent like the last few years having the top informaticians in the world work on these FHIR data models and work on these FHIR APIs. So can we use those resources that we've created, those artifacts we've created, to support these population level use cases? Can we use FHIR resources as the data model behind these transmissions instead of mapping to manual CSV formats? Can we use the FHIR Operations API to kick off these data extracts? And can we use the SMART backend services OAuth profile to support authorization for these use cases? So it's done the same way everywhere. And one of the neat things that comes out of this is if you're using these standard components, you don't have to build everything into your bulk extract API. You can kind of have modular components that handle specific pieces of your ETL pipeline that can talk to each other using these APIs. So in this first example, you might have an EHR that that has a bulk data export interface, and then that interface could be read by a de-identification transformation that also exposes a bulk data interface. And then that might be read by an ETL module, which could then put the data into a research database. And if you want to swap out and use a different type of de-identification, you could use, because these APIs are open, they could both implement the same bulk data APIs and just kind of plug into that pipeline. And I'm not going to go through all the examples here, but there are a lot of other cases where this makes sense as well. And it's really powerful once you have open APIs for this. And so, when we started this project, we decided that a few things were out of scope. And so I think it's worth reviewing those because I think a lot of these are important problems that still need work. We just decided that they're not necessarily part of a bulk data API right now. And so the first piece is a legal agreement. It is the legal framework for actually sharing this data. And so what we're assuming is that the two parties that are exchanging these bulk data files have business associate agreements in the US, that's a requirement, have service level agreements, have data use agreements around what they're going to use the data for, kind of in place, negotiated out of band, contract signed. I think there's an opportunity for a really good project to try to standardize some of these legal documents and get multiple institutions to use the same ones, which would make things a lot more efficient. But really, we're talking about a technical solution here which doesn't address the legal side of it. Similarly, we didn't really address real-time data. We're trying to kind of build an incremental step on what people are doing now. And there's a lot of really interesting work around kind of streaming updates and different ways of doing kind of more granular immediate updates. But this is really around kind of bulk batch transfer as a way of kind of meeting hospitals and healthcare institutions and providers where they're at now and moving it just a little bit further down the road. I think in future versions, I'd like to see in version 2, version 3, version 4, we start to look a little bit more at that. What I will note, though, is if, for example, you're dumping data nightly into your care management system, you can still use the regular FHIR APIs to supplement that data. So once you pull up a patient, maybe they had a visit in the last day and you want to have that reflected in what the care manager is seeing, you can still do that using the synchronous FHIR API calls and just having the bulk of the data preloaded. Data transformation, as I mentioned, this can be part of the pipeline, and I think it would be great if different data transformation modules included this API, but we're not building that into the API or hard coding any specific flows for that. And then the last piece is around patient matching. So if you get these bulk data files, you probably want to match it to patients in your analytic database or in your EHR. And we're not precluding that, so you can still use the FHIR patient demographic information that comes through, the patient's name and address, date of birth, and potentially other identifiers like subscriber numbers if they come through in the FHIR data to do the patient matching, but we don't dictate any particular algorithm or approach as part of the bulk data project. So let me just check how I'm doing on time. OK, so what does this look like? How does this flow actually work when you do it in practice? So here on the left side of the screen, we have the bulk data client, which is the system that's requesting the data. And so you might think in a lot of cases that'll probably be some sort of middleware that'll pull down the data and then kick off an ETL process to load it somewhere else. On the right side here, we have the bulk data server. That could be an EHR. It could be a clinical data warehouse. It could be a cloud environment. And so the bulk data client makes a kickoff request to say, start this export. And that's actually a FHIR operation and that we're calling $export. FHIR operations start with a $. And we've defined kind of 3 FHIR operations that you can kick off under this bulk data export operation. The first one is at the patient endpoint in FHIR, and it's patient/$export. And that's saying, give me all data on all patients in your system. So you might, in the care management example, maybe you want to dump all your patient data into a different system periodically. And so that's the sort of export you would use. The second operation is actually building on top of the FHIR groups, the group FHIR resource. So FHIR has a resource where you can define groups of patients. And so we take advantage of that and say, you're going to specify a specific group, and then for that group, you can do an export of all the patients' data in the system. And so you can imagine that would be useful for a payer that had a particular group of patients that they service or that are their subscribers, and they might only want to be able, you might only want to export data from that particular payer's group, or it might be a cohort of patients who are in a study. So you define these groups using the regular FHIR API calls, and then you can call $export to do the actual export. The third group is actually one that came from feedback from the community as we were developing this. This wasn't in kind of the initial idea, is an export at the base level of the server. And the difference here is when you do an export at the patient level, you're only getting resources that would be in the patient compartment in FHIR, things that are related to a patient. But you might also want to do a server backup. Like maybe you want to move your server from one cloud provider, or move your data from one EHR to another, or you want to put all your data into a cloud environment so you can do analytics. So you might want things like value sets that aren't tied to a specific patient. So doing this export at the root level of the server will give you that data too. And then the last thing on the slide is a header. It's actually not a URL. And that's these bulk data exports are asynchronous. And so when you kick it off, you put in a header that says you want the server to respond in an asynchronous way, which means that if you think about a server that's exporting data on hundreds of thousands of patients or potentially millions of FHIR records, what's probably going to happen is you're going to kick off the request, and then the server is going to kind of grind on that for a while and pull out all your data and create files, and then you'll check back and it'll let you know when it's done. And so rather than keep an HTTP connection open for that entire process. And so that's what this asynchronous flow does. And this asynchronous flow has actually been pulled into the core FHIR spec after we defined it for this operation. And so it's, in theory, it can be done for any FHIR request. In practice, what for export, we're really requiring it as the only way to get a bulk data export. There's also a couple parameters you can put on this initial request. The first is output format. I'll talk a little bit more about that in a bit, so maybe we'll just skip over that for now. But the short version is that we're requiring that servers support a format called NDJSON, but also allowing potentially other formats as long as both the client and the server can handle them. We have a since parameter. This is really important. So this lets you do incremental updates. So you can say, give me all records that have been modified since a particular timestamp, but no other records. And as part of the response, which I'll show you in a minute, the server will tell you the timestamp it used when it generated that data set. So you can kind of use that in your next request, because any data past that timestamp will be data you don't already have. There's a type parameter where you can list specific FHIR resource types that you want. So if you have a system that only works on, for example, lab results, you probably don't need a list of the patient's conditions. So you can say, don't give me all the data, just give me demographics and observations, patient and observation resources. Group ID we talked about a little bit. And then type filter is an experimental part of the spec, or part of the implementation guide, that defines a term where you can do kind of more advanced filtering. And the reason we labeled this as experimental is it hasn't really been tested in a production system yet. And so it's fairly complicated, and we really want some feedback about how necessary it is, and kind of are there subsets of it that are simpler that we could use instead. So it's something to play with, but something that we're not expecting servers and clients to necessarily implement at this point. So after the request goes to the bulk data server, the server responds with a content location. So this is where the client can check to see how far along their request is. So the first response you get is a 202 accepted, meaning the server's accepted it. Of course, it might also return an error if there's a problem. And then it gives you a content location, a place where you can check for status. But also, if you want to cancel the request, you can send a HTTP delete operation to that content location to tell the server that I don't actually need this data export anymore. So then the client can pull this content location. And the server will return a response of its progress. And we left this fairly vague in the specification. Right now, this particular example says 50% complete. And you can imagine that some sophisticated servers will be able to tell you exactly how far along they are in your request. But we also wanted to leave open the possibility of servers that might hand off the job to a background process and not actually know anything other than the fact that it's been submitted or it's in progress. And so the server has some latitude here around what it returns. The server can also give hints to the client using this retry after header to say, like, I think I'll be done in about 120 seconds. Why don't you check back then? So that clients don't have to poll on a very frequent basis. So let's say we poll again. This time we get a 200 OK status, which means that the request is done. And in the body of that request, we get this response JSON object. And so this is kind of interesting. This is the actual result of your bulk data export. And so you get a few things here. You get that transaction time that we talked about, which you can use in subsequent requests to say, give me everything after this timestamp. You get your request reflected back on line 2 there. On line 3 is an indicator as to whether you need to provide your authorization token to get these files. And we'll talk more about that in a second when we talk about the security aspects of this. And then you can see under the output section, we have a couple objects, a couple sections around different file types. So the first one is a file of FHIR patient resources. And you can have multiple files per resource, but not multiple resource types per file. Multiple files per resource type, but not multiple resource types per file. So what that means is that the server, if it has a lot of patient resources, that's probably not the best example. If you had a lot of observation resources, the server might split it into multiple files and put each one in a different section. But what the server won't do is mix patient and observation files, resources in the same file. And that was, again, that came from the community, where folks who are doing a lot of ETL into large systems wanted to be able to approach different FHIR resource types differently and didn't want to have to kind of do that filtering at the ETL level. So part of the spec is that the server will give you unique files per resource type. And then the last section is an error section. Servers have an option of kind of just bailing on the whole request if there's an error and saying, hey, I can't do this. But they also, and you can think about this in the context of where you're, let's say, exporting data on 1 million patients, and a few hundred of them have problems, or 10 of them have a problem. You might not want to negate the whole export. And so the server can return a set of operation outcome FHIR resources with specific errors that occurred, but still return whatever data it can return in these files. And then, of course, the client can go out and pull down these files with the data in them. And this is a good time to talk about the format. I'm not going to go through what FHIR resources are. I hope by this point in the conference, everybody's somewhat comfortable with that concept. But these FHIR resources, here's some examples, are serialized into JSON. This is the standard FHIR JSON format. What's different is that instead of putting it in a bundle where you have to kind of read the whole bundle into memory in order to parse it, we use a format called NDJSON, which is a fancy word for new line delimited JSON. And what you're really doing there, and these red parts, I got a question about this, so I think it's probably not as clear as I'd hoped. These red parts that are circled are the parts that are missing in these files. So this is something you would normally see in a JSON file that doesn't appear in NDJSON. Instead, you just get the individual FHIR resources, one per line. And this is important because it enables you to do streaming reads and writes. You know, as you're reading the file into a system, you know every time you hit a new line, that's a FHIR resource that you can load. And similarly, when you're writing it, you don't have to worry about writing data to the end of the file or writing data to the top and holding the whole file into memory. You can just kind of write resources as you process them. So this is the NDJSON format. As I mentioned, that's kind of the default format that everybody has to support this implementation guide. But they don't have to. But they can also support other formats like binary formats, as long as both the server and client support them. In terms of authorization, the bulk data implementation guide recommends but doesn't require a OAuth profile for server-to-server authorization. So this is a little different from kind of the SMART on FHIR authorization you may be familiar with, where a user gets prompted to log in and approve access. Instead here, there's kind of an early step where there's a configuration, where the client sends a public key to the bulk data server and gets configured with a client ID associated with that public key. And in practice, we imagine, at least initially, this will probably happen through a business analyst. Again, remember, there's legal agreements that have to be signed and other things like that. So there's probably a configuration step where the client registers its public key with the server. But then subsequent to that, there's no human intervention needed when the client actually wants to make a data pull request from the server. Instead, it simply signs a JSON object that kind of outlines that it wants a token, and then the server signs it with its private key. The server gets that token and then uses the public key to decrypt it, and then provides a token back, gets that token request, and then provides a token back that the client can use. These are recommended by the security folks to be pretty short-lived tokens, like 5 minutes. So what will happen is the server will periodically have to request additional tokens as it makes these FHIR requests. But the idea here is that you don't actually need to log in. Once you're set up, the server can do it. And there's support for key rotation that was, again, added at the suggestion of the community, where you can actually store your keys at a URL and provide that URL instead of the key itself, so that you can change your keys at different times without having to involve somebody at the healthcare institution or at the data source. So I included some slides in this deck that I'm going to skip over. I forgot to mention it, but I had the URL for the deck up at the beginning. I'll put it up again at the end. So some of these are there mostly in case people are interested. But if you've heard my presentation on bulk data before or looked at this spec kind of early on, there have been some fairly material changes. And so I put in a couple slides with those changes. But I'm not going to go through it right now in the interest of time. I did want to talk about some tools and resources that have been created around the spec that are really useful if you're trying to build clients or understand how servers work. The first is a reference implementation that the SMART on FHIR team put together. And this is actually a really neat server that we built. It's a fake server that enables you to do a lot of different testing scenarios. So you can ask the server to give you an error at different points in the process. Or you can say, I want it to be a very slow server, or I want it to split up my data across a lot of different files. And so you can try different scenarios with your client and see how they work. This isn't a production server. I'll talk a little bit more about in a minute about kind of what people are doing to actually implement these specs. But I think this is a really great resource, and it's open source and also public. So and this is a live link, so once you look at the presentation, which is online, you can get to it. Vlad on the SMART team also built a GUI client, a UI to kind of play with the client side of the spec. This isn't actually the sort of thing you would do in production. It's generally, these are probably machine-to-machine transactions, but it's a neat way to play around and see kind of what sort of responses you get from a bulk data server to different types of queries. This is maybe more in line with how you would expect a bulk data client to work. It's a command line driven interface that Vlad also made. That can connect and authorize against different bulk data FHIR servers as a reference implementation. And so this is open source on GitHub, and you can check it out. So how real is this, right? I think this is always my question when I hear about new specifications, new implementation guides, new technologies. It's not quite there yet, but it's getting there. So where we are in terms of the standards process is the bulk data implementation. So as I mentioned, the async piece has been pulled into FHIR R4. The bulk data implementation guide has been through the initial stages of validating through HL7. I think that'll probably get finished this year and become an actual standard. And then people are starting to try to implement this. So CMS has a public sandbox where you can look at beneficiary claims data or pull down beneficiary claims data using the bulk data API. It's still a work in progress, but they're working on it for future production implementation. Boston Children's Hospital is working on a pilot to do payer analytics using bulk data exports that get imported into an analytics platform. That won't be public because it's actual patient data, but the code behind a lot of those pieces is going to be open sourced probably later this year, possibly early next year. And then several of the cloud vendors are working on implementations of the bulk data export spec as well. And then EHR vendors were really, really helpful in providing early guidance in the spec and it participated in the Connectathons. We had Epic and Cerner involved in both the Argonaut work on this as well as Connectathon work. And I think there's a chance that, at least in the US, as part of the 21st Century Cures regulations, it talks a lot about population data. So the final rules may require use of what will hopefully be an HL7 implementation guide at that point for bulk data, at which point I think we'll see also some more adoption. But I'd encourage you, I think the spec is fairly solid, and I think even if you're just using it internally at your organization, it can provide a kind of a standard way to move data around between systems. I think in the interest of time, I'm not going to go into the import operation too much, but you can imagine that we have an export operation, right, to get data out of systems, and it would be great if there was also a standard way to import data into systems. And so really at the last Connectathon, so it's only been a few months, we started working through as a community, what this might look like. And so these are more slides that I kind of threw in for people who are interested, but it's really early stage work, so keep that in mind. The export stuff is much farther along, the import stuff is early. But I think it's a great time to get involved in that and help shape it if you're interested at all. The one thing I will point out, I think is worth looking at the import kickoff. This is an example of the operation that would get, or the data that would get posted to kick off an import operation potentially. And there's a couple things that are different from export here. One is that, of course, you're providing the data in ND.json files instead of getting it out. So that's kind of the main difference. But we also added the storage detail section, and it would be great to get some feedback on that. That section allows you to have the data available via HTTP, as in this example. But also, we wanted to open it up where if you have the data in a bucket at a cloud provider, like an S3, maybe there's more efficient ways to move that data from that bucket into that particular cloud provider or even a different cloud provider server. And so to allow some of those efficiencies, we were thinking about having different ways to define different storage details for different types of data storage so that you can load the data differently. And it would be great to get some feedback on that. So I'm going to kind of zoom through the import stuff. I have the rough proposal here, and it would be great if people check that out and provide us with some feedback. So in terms of next steps, we need to complete the export operation standardization process. That's kind of underway. We're integrating some comments from the ballot, mostly around clarifications on the documentation. We want to work on this import operation, which I think will be a nice parallel operation to work with bulk data. And definitely, please get involved there. We need feedback on how this works in real-world use cases. So even if you're using it within an organization, does this work? How do we want to change it in the future for version 2? There have been some people who are interested in working on standardizing group management. So if you have a roster that comes from a payer, can we figure out a standard API, a standard way to convert that into FHIR groups so then that payer can only pull data on their subscribers? So I think there's an opportunity for some work around that if people are interested. And in terms of getting involved, if you've kind of followed this presentation and you want to work on some of these things, I think implementing servers and clients would be a great way to do it. I think I'd really like to see some open source components that can go into an ETL pipeline that use these open APIs. So if you have a de-identification or a data transformation application that you've written, provide this open API on it and let people actually use it with their real FHIR data. We always need good sample data sets for testing, so maybe that has to be done within your organization if it's real patient data, but I think that's helpful. Right now everybody's using Cynthia data from the MITRE Cynthia project, which is incredible, but since everybody's using the same data, we run the risk of kind of having people all come up with the same solutions, and I think it would be helpful to have more options. And then if you have ideas about the design of the import operation, we're going to have a track at the September Connectathon in Atlanta. And so that would be a great time to come with your ideas and hopefully with some sample implementations if you have specific things you can implement. So this is kind of the link slide if you're going to take a photo of a slide. The upper right corner there is the link to this deck, which has all the other links in it, so it's kind of a meta link. And then we have the bulk data implementation guide draft, which is kind of getting the final revisions now. There's the SMART reference server I mentioned, the SMART reference client. And then the other place, I mentioned the Connectathons a few times. The other place a lot of the work happens around this is on the FHIR Zulip chat, chat.phir.org. We have a bulk data stream, which is pretty active. And so that's also a great place if you have thoughts or suggestions to kind of jump in. And then I wanted to close with one example that's kind of peripherally related, but I think really highlights one of the advantages of working with these open standards. And that is that there's, and I stole this query from the FHIR Storage and Analytics track, which is working on kind of standardized ways to query FHIR using SQL. And I really like this query because they don't do dramatic transformations on the FHIR data. In fact, they're taking these raw ND-JSON files directly as they come out of the bulk data export, and then using Apache Drill, although there are other tools as well, to query across it. And this is a fairly simple query, just as an example, that looks for different types of kind of counts observation codes. But you can imagine somewhat more sophisticated queries doing things like looking for specific patients who have gaps in care or things like that. And because the data is coming in a standard FHIR format, you could imagine bulk data exports from multiple systems or in multiple places using the same SQL queries, because now we know all the data is FHIR. It's not in a proprietary format that got mapped from CSV or something like that. So this example, I think, is a great way to show the types of things that become possible once you have data in a nice structured format. So those are the things I wanted to cover. I think we have a few minutes for questions if folks have questions about this. Yeah.
So the example that you showed was like the patient compartment, right? But the other operation that you had was like the give me everything in this server. Right?
Yeah.
So in that scenario, you don't want like all the files to come at one go, but you want to see them as it goes, right? Like maybe 10% is done. I want to get the results for it. Is there support as well, or?
Yeah. So in case folks didn't hear the question was about. And correct me if I misstate this, was about incremental, kind of getting the data as it's being generated rather than waiting for the data to all be there. Let me flip back in the slides. There are a lot of slides. Oops. So this is the kind of the final response. And so that's a really good question, and it's something we actually went back and forth on a little bit. I think for version 1, we kind of decided that to reduce complexity, and because there are a lot of servers with different capabilities, we would wait until all the files are generated and then give the response to the client. I think down the road, there's a lot of opportunity to kind of provide some of the data as it's available in a structured way. But right now, it's kind of a little more batchy, where you kind of wait until all the files generated and then you get this response. That said, there are some servers, at least on a test basis, that are doing that. So these URLs for files don't necessarily have to be actual data written to a disk, right? They could kick off a data stream from a server. So here, when I, for example, got patient file 1.ndjson, that might actually be something that kicks off a live operation on a server that then kind of streams me ND-JSON, or I guess JSON rows. So you can kind of have a little bit of that by providing this response quickly, and then as the files are requested, doing the streaming. Yeah?
I may have missed this, but I'll ask the question in a minute. I'm thinking about query that does query equivalent to bulk query across 55 different nodes. Is that accommodated with this, so I can do those presumably in parallel, but combine all the results and do the analytics on that? Is that part of where you are now, or is it each individually done at each site and then putting it together separately?
Yeah, so let me make sure I understand the question. So the question was, could you use this to query across multiple sites?
Yes.
Yeah, so right now, you could. You'd have to kind of set up your client to be able to talk to all the sites as a kind of a one-time setup. But then, at least in theory, once the sites implement their side of the bulk data, then a client could pull in data from all the sites. There are still some complexities in terms of integrating the data in analytics, as I'm sure you know, where you would have to kind of adjust some of the IDs, right? So every site is going to have its own FHIR IDs for each resources and for the relationships between the resources. And so when you pull that data into an analytics platform, you'd have to probably replace some of those with your own IDs so you don't get conflicts between the different IDs. And so that's some of what we're talking about on the import side, is how do you like keep the provenance data around where these resources came from and what IDs they were at the source, but integrate from multiple systems that are completely disparate for analytics. Yeah?
So how are the references managed in between? If you have one resource type per file, how are the references managed between them?
Yeah, so that's a good question. So we don't actually address that. So so basically what happens is all the references are internal to the system you're exporting from. And so the references between the different resources in the different files will match to the resources in the other files. Now, when you load them, that creates some complexity, right? You probably have to do an ETL operation where you put all the data together, change the references, and kind of validate. And if you care about referential integrity, validate that you have no broken links or that your links aren't broken. So it's really kind of not, it's kind of out of scope for the export piece, but it's certainly in scope for the import piece around how you would handle that in a server. Yeah?
So to add to that question, what would you do with resources that are referenced but are not part of the patient record, like medications?
Yeah.
Do these come along, or do you have to go back and grab them?
Yeah, so they don't come along automatically. You could use, potentially, you could use that first operation at the root level of the server with a resource type equals medication to just pull those in. But that would be a separate request than the patient data.
You have to know to do that.
You have to know to do that. Yeah, I mean, potentially, depending on how a server implements this, it could decide to hand along some things with it, but it's not part of the spec. Yeah, so.
So I noticed the whole workflow is built around files and extraction. I'm assuming there was thought into it, but like instead of posting like a webhook and it being delivered somewhere, because the first thing I think of is if it's a large data set, I'm going to take it down and then just push it to a pub sub system anyway to get processed. I assume that was measured and discounted for some reason.
Yeah, so there's a few things there. So one is that once you have this response body, you can actually, for the individual, when you pull the individual files with the data in them, you could pipe that directly into an ETL operation or to another system. So all you're getting here is really the pointers to the files. In terms of hooks, which, sorry, I haven't been doing a great job of repeating the questions. The other question was around a webhook or some notification, I think, rather than polling to check when the job is done. And that is something we talked about. And I think the group decided that for version 1, for simplicity, since a lot of these systems have different firewall considerations, polling was the simplest option, although we added that retry after hint that the server can give to the client, so it's not kind of constant polling. But I think certainly an area to look at kind of down the road is whether there's, whether you could just have a webhook to kind of pass this information along and say the request is done or these files from the request are done, so you could get the data faster. I think really in version 1 we tried to err towards fewer features but simplicity to try to get this out in the world a little bit. But I think that's part of the implementation feedback we really want for version 2 is to say, hey, I'm using this, but the polling is killing me, and so we want to go back to, we want to have some sort of webhook or some way of notification.
So to follow on that, some of complexity is getting pushed back the other way, because if you have a clinical trial that's accessing a ton of different FHIR databases, they now have to manage all of the polling on the client instead of passing it off to the server and being done. So there is still complexity there, it's just moving to the other side.
Yeah. Yeah, so just in case folks didn't hear that, because it's a big room. So the point was that we still have some complexity with the polling. It's just getting pushed onto the client instead of the server. I think that's true, although outbound HTTP requests tend to be easier with firewalls than than inbound requests, and also have maybe some simpler security implications. So you do have some additional work there on the client, but there's some advantages too. And then there was another comment that you could kind of, if you really did want to have webhooks, you could have an intermediate module that kind of converts this into webhooks and does the polling for you, and then when your data is ready, calls that. And so that, I mean, that's exactly the sort of implementation guidance that's really good for version 2. If people are building that and need that, then that's a pretty strong indicator that we missed the mark here, and that there should be some sort of webhook response, when the data is ready. Great. Any other questions? Oh yeah.
I'm still trying to understand why I understand why you're breaking different types of resources into different files, but if and that's one in this case, but if separate maintaining, if the file is an HTTP entity, that's what was never for, but why not use the HTTP chunk encode if you want to avoid having transmitting too much data at once?
Mm-hmm. Yeah, so the breaking it up into files by resources, so the question was, why not just use HTTP chunk encoding rather than kind of breaking it up into different files? And it's certainly something, I think that would be a good kind of offline discussion to have after the session, because we're also, it looks like, kind of running out of time. But I think kind of the core idea here was to take something people are very comfortable with, which is kind of moving around these files, and use that paradigm. So I think a lot of people know how to kind of ETL a file of observations, whereas if they have to kind of switch modes in a single kind HTTP transmission and start to route the data in different places, that might add some complexity. But I'm curious to hear more about that, so maybe we can touch base afterwards. Okay, so I think it's time for the FHIR wrap up. So I'm going to end with that. But thanks, everyone.